the description below. Also, don't forget to click that subscribe button to stay up to date on all the videos that we have coming out from the channel. All right, so let's get started. So here we have this vector 4i minus 3j. And what we want to do is we want to first draw a picture to see what we're looking at. Now, a vector is just a change in position. So 4i means that if we start at the origin, then we're going to move 4 spaces to the right. Positive. So our x value goes up by 4. But the minus 3j means our y value goes down by 3. So if we start at 0, 0, then we end up at 4, negative 3. And so there is our vector. Now the question of the magnitude. The magnitude we could think of as the length of this vector. And so we want to know how long is this right here. Well, this is we could think of as the hypotenuse of a right triangle, where this side is 4 and this side is 3. So using Pythagorean theorem, 4 squared plus 3 squared equals c squared. So we get 16 plus 9 equals c squared. So we get 25 for c squared, which means 5 equals c. So this is our magnitude. That is the length of the vector from where we started to where we finished. And that's how we compute it. So looking at this second one, we have negative I plus 2j. So if we graph this, if we start at 0, 0, we're going to move 1 unit to the left, and we're going to move 2 units up. Let's move that over a little bit. And so we end up at negative 1, comma 2. All right. So if we want the magnitude, we could think of this and this as sides of a right triangle. This is 1, and that's 2. So again, with Pythagorean theorem, 1 squared plus 2 squared equals c squared. So 1 plus 4 equals c squared. So 5 equals c squared. So that means square root of 5 is equal to c. And there's our magnitude. Now for this next example, here, it's a little hard to tell where we're going because we need to figure out cosine of 225 and sine of 225. But if we use our unit circle, we get negative square root of 2 over 2 for cosine and negative square root of 2 over 2 for sine. So this vector moves negative square root of 2 over 2 in the x direction and negative square root of 2 over 2 in the y direction. So it's going to move down here. So our coordinate negative square root of 2 over 2, comma negative square root of 2 over 2. So to find the magnitude, we think of these as sides of a right triangle. Square root of 2 over 2 and square root of 2 over 2. So applying the Pythagorean theorem, what's going to happen is when we square these, we're going to get 2 on top and 4 on the bottom. And so when we add these, we end up with 4 over 4 equals c squared, which is just 1, which means when we take the square root, we also get 1. And so that is the magnitude. This is exactly 1 unit away. The end point is 1 unit away from where we started. All right. Now looking at number 4, same thing. We have cosine of 2 pi over 3. So we still have the 2 out front, but we're going to deal with that in a second. So cosine of 2 pi over 3, that is negative 1/2. And sine of 2 pi over 3 is square root of 3 over 2, j. But then we have to multiply in the 2. So we have negative 1i minus square root of 3, j. So that means that starting at the origin, we're going to end up down here in the third quadrant at the point negative 1, negative square root of 3. So if we think of these as sides of a triangle, we have 1 and we have square root of 3. So 1 squared plus square root of 3 squared equals c squared. So 1 plus 3 equals c squared, which is 4. So that means our magnitude is going to be 2. Now, in all of these, we had 2 components, and we applied the Pythagorean theorem. Now, for this last example, here our vector has 3 components. Now, it's a little harder to draw in 3 dimensions on this piece of paper, but everything we've done up till now has been using Pythagorean theorem, which means this will as well. So what happens is we take each of the 3 components and square them all. So 1 squared plus 4 squared plus negative 2 squared equals the magnitude squared. And so Pythagorean theorem extends into as many dimensions as we need. And so this will give us the distance from the start point to the end point. So 1 plus 16 plus 4 equals the magnitude squared. So we add those together and we get 21 equals our magnitude squared. So square root of 21 is the magnitude of this vector. And so if we had 4 components, we would square them all and add them up. And that would equal the square of the magnitude. And you can do that for as many dimensions as you need. Thanks for watching. If you liked the video, please give it a thumbs up. If you have suggestions or problems you want to see work out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the best way to understand something is to do it.